Hi everyone, this is Group 11, and our topic is detecting saltwater intrusion in rivers. And so, starting off, what is saltwater intrusion? So, saltwater intrusion happens when saltwater from the ocean flows upstream into freshwater rivers. And this can be caused by a number of different factors, many linked to climate changes, like sea level rises, storms and tides, drought, and it can also link to more for human manners, like water management and artificial waterway. And in general, saltwater intrusion can have large influence on coastal ecosystem, such as coast forests and eutrophication, which is the loss of nutrients in forest area. And moving on for a project. For a project, we're using a satellite's image to analyze salinity and water quality of coastal blackwater rivers. And because it's really difficult to measure salinity directly, we choose to use color instead. Because normally with organic matter in the river will turn out to be black, and with the sea level rises, the organic matter will bind with salt in the water, making the river non-black. So we're using this phenomenon to really dive into how salinity changes and water quality changes over time. And for a project, we're expanding on past research by Dr. John Gardner, and to monitor river color changes and patterns over several years. And we're using satellites image datasets that are spanning for 40 plus years, and to also identify seasonal patterns, which include redshift, blue shift, and color distribution, and so on. And the aim of our project is to use a much more comprehensive list of rivers and streams, and to also create an interactive R-Shiny app to display the data.
We had four main categories of resources that we used for this project. The first one is the National Hydrology Dataset, which is where we got all of our flowline geometries from. Second is Google Earth Engine, which is where we stored all of our assets and accessed the satellite image datasets. And speaking of satellites, the ones we chose to use were the Landsat and Sentinel-2 missions. And then finally, we used Python and R to do all of our data downloading and post-processing. So to explain our general methodology, we're going to run through an example, the Osceola River in Florida. So our first step is to map the flow line and get the overall path that the main stem flows down. And then second, we'll buffer that flow line about 100 meters on both sides so that the pixels that we're taking will reach the banks of the river and get as much water data as possible. Third, once we're parsing through all of the satellite images, we'll apply cloud mask to them, which takes out all of the clouds and only leaves the clear pixels. And then finally, we'll apply a water mask to our buffered pixels, which cuts down on land and vegetation, and our final product is what you see on the bottom right outlined in red, where it only leaves the water pixels behind. So that cuts down on a lot of our storage requirements as well as processing time.
Moving on to our results and analysis, we have three graphs here, which represent the mean reflectance of the Chowan River, which is a pretty big river in North Carolina. And the three graphs represent three different sections of the river. A far upstream segment, one kind of in the middle, and then one right near the mouth. And as you can see by looking at these three graphs, the variability of the mean reflectance tends to be greater as you get closer to the mouth of the river. And this could be due to a number of reasons. The mouth of the river is more prone to saltwater intrusion and potential wastewater or other environmental factors that could change the color of the river over time. However, looking at the scale of these graphs, the changes are pretty small and could be insignificant. Next, we have a graph of the mean surface reflectance across 1 year, in this case 2011, of the mouth of the Chowan River. And as you can see, there is a rise in the surface reflectance in the summer months, which is to be expected. The conditions of the river change as the seasons change. For example, in the summer, you tend to get higher chlorophyll concentration and stuff like that, which could account for the river getting slightly brighter. But again, the change is pretty small. And lastly, we have a graph of the chlorophyll concentration over time. This is from 2020 to 2024. And you can see this kind of spike between 2023 and 2024. That red line actually represents a algae bloom that happened in the Chowan River. I believe it happened in July 2023. And so you can see that the chlorophyll concentration rises after the algae bloom, which is to be expected, of course. And you can see that happening from the data.
So for conclusion, we have created a data set of the rivers along the US coast, and through remote sensing, we're able to analyze their water qualities and salinity levels. So first, by monitoring their main surface reflectance, we can see the patterns in black water occurrence and predict the general trends for the future. And second, we have also designed a website and our Shiny app to better visualize your conditions. And we also use plot tools such as float light colors and various graphs. And finally, there may be some potential errors because there are differences in quality based on the different satellites. And we have also have the issues of lack of data over specific time periods due to cloud covers or other weather phenomena. So for the future, we need to understand the impact of these factors to reduce the errors. And this is our website. So for the website page, the first page, which is also our homepage, which discusses what is saltwater intrusion and the causes of saltwater intrusion, and why do we care about saltwater intrusion. The second page, our project page, which detailing our methodologies for the project, what method we use, what resources we use. And the third page is our analysis page. And this page, this is our Shiny app. So in this app, if you zoom in to see the US coast region, you're able to see there are flow lines right here. If we clicked one comment right here, it will show the river's name and its chlorophyll level over time, reflectance level over time, and salinity ratio over time. Thank you for watching our presentation. Let me know if you have any questions.